Okay, we have another interesting looking integral here on the board. This one's from MIT 2011, problem 13. We have the integral of dx over 9 cosine squared x plus 4 sine squared x. You know, it's interesting. We know that cosine squared x plus sine squared x is 1, but having these different coefficients on it makes it a little harder. You notice they did this where they have perfect squares. Like you could write this as 3 cosine squared plus 2 sine squared. I don't know, I had a whole bunch of ideas, but what I came to as a pretty good way for this was to multiply the numerator and denominator just by secant squared x, noticing that that's going to kind of cancel out this cosine squared x. Let's just multiply this through and see what happens. So now in the numerator we'll have secant squared x dx. Like I said, a secant squared x and a cosine squared x is going to cancel, so we're just going to have a 9 here. And then we're going to have 4 sine squared x times secant squared x is actually going to be tan squared x. And now you may see why this trick is so effective, multiplying by secant squared x. It's because the derivative of tan x is secant squared x. So we're setting up a u substitution here. And so let's just do that and see if this simplifies it even more. So I'm going to call my u equal to tan x. And like I said, du will be secant squared x dx. And we'll rewrite this whole thing with our whole numerator being du. Then the denominator, we're just going to have 9 plus 4 u squared. I think what I'm going to do here is actually I'm just going to factor out a 4 from the denominator, so we're going to write it as a 1/4 in front, and we'll have du over, I'm going to switch the order, so we'll have u squared plus 9 over 4. But now we're in a good position to use our arctan formula, and what I want to do is let's write this, instead of having this as 9 over 4, let's write it as 3/2 squared. Okay, and we'll just take a quick look at our arctan formula over here on the right, so we can use this because we're in the exact right form. Noticing we have our variable squared and we have our a would be 3/2 here, okay? And so what we'll do is we'll apply this. First we have our 1/4 out front. Then applying the formula, we'll have 1 over 3/2. That's just the reciprocal, so this is going to be 2/3. Then we're going to have arctan or inverse tan, and we'll have our u over, again, 3/2, but that's going to be 2/3. And so then for our final solution here, we'll just multiply 1/4 times 2/3, and that's just going to be 1 over 6. Then we're going to have our arctan 2/3, and back substituting our u, we're going to have 2/3 tan x plus c, and that's it. Okay, pretty good problem today. We'll stop it there. Thanks everyone for watching. Please subscribe. Have a great day.